Hello everyone, this is the video lecture for Calculus 2, section 6.3, shell method, the long-awaited shell method. Volume is equal to 2 pi times the integral of x times f of x dx. And the reason why we're using shell method is because we're going to be going around or about the y-axis. That's its main function. Notice that we have dx, but we're going about the y-axis. That's something we have not been able to do with disk method so far. And so the idea is that I have something going on here, and I go out to some x value, and I'm revolving around the y-axis. Okay, so it's actually pretty cool because we haven't been able to do that so far. I've always had to change it from x to y to x, and da-da-da. But now we can actually do something better. So this is x times f of x, and they give more specifics, I think, in the book. This is actually your height, and this x right here is the distance from the axis. Distance from the axis. When they, because they will, when they shift it off of the y-axis onto something else, then we'll actually have to do something about shifting that distance from the axis as well. Of course, as you probably already guessed, the very first problem has not much that we need to do. Okay, well, it's a good problem, but it's like, I gotta give this a name. It's like first problem disease. And it's just always the first problem is not the best problem. It's not a good representation. I'm going to do this with you. I think they're trying to say, look, you can use disk method, but shell method's better. But when the next problem's actually better. So we'll just do whatever we can and it'll be okay. So here we go. X times y is equal to 5. X is equal to 0. Y is equal to 5. Y is equal to 7. And they say go about the x-axis. Now, when I see x-axis right now, you and me right here, I think disk method, and I'm not going to be afraid to do disk method if that's actually what's going to happen, okay? So shell method, disk method, either way is fine at this point. So I need to graph this thing, and the best way I know is y equals 5 over x. And so I can graph that. It's kind of like this. There we go. Of course, there's a negative component, but I don't think they're going to be worrying about that here. X equals 0, so right here. Y equals 5, so 1, 2, 3, 4, 5, and then y equals 7, 7, and they want to go about the x-axis. So this little chunk right here, and they want to revolve it. So to me, it looks like it'll have this kind of lip thing on the outside, and well, that's basically what it would look like. So on the inside, it's just kind of flat, I guess. So it's a ring, but it has this little lip thing, I guess. There. Now it looks a little bit more better. More better. That's proper math English, right? More better. So honestly, I don't really know how I'm supposed to tackle this thing, but the best way I know is I could do disk method. Right? Don't have a top and a bottom. But we saw this once before where we're going to have a top, and then we have another top and bottom. We have two different problems, and it's really not very fun, and I don't want to do that. So they're saying, oh, well, shell method will be a lot better. Okay, cool. So now we have to convert our axes again, and that's fine, because guess what? It's now x equals 5 over y, same kind of thing, same kind of graph. Okay, and so then my y is now going from 5 to 7, right? 5 to 7. And there's my little part there, and now I'm going about this x-axis here. Same x-axis. All right, but notice now that I have, like, I guess you could say horizontal values and a vertical axis. Now we could do shell method. And again, I dislike that they already had us change our axes to get this done. I could have just went to problem number 2 and done a normal problem, but, you know, that's fine. So my volume is equal to, and my formula here, Oh yeah, I gave you the formula. 2 pi. Remember this 2 pi? That's a small difference. Normally, disk method has just pi. Here, shell method. I'm sorry, disk method is just pi. Shell method is 2 pi. So just that's an often common forgotten thing. Just forget the 2. Just watch out, okay? So we got 2 pi integral of, and simply put x times f of x dx. Whoa, 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 whoa. These are y values. We go back and modify it. Y times f of y dy, I guess. I'm basically saying my function in terms of y, you know, pieces with y's in there. And so, yet again, I convert this over to 5 over y dy. So that's where I got those from. I had to like construct it for you in pieces so that you understand where I got it from. So these y's actually cancel, and I just get a plain old 5. Cool. And then so I got now 5y, and from what? I never gave you any limits, did I? Well, can you tell the limits? It's pretty easy. It's 5 to 7. And so then I plug in my 7, and I plug in my 5, and I get my 2 answers. So 10 pi times 7 minus 5. That's a 2. And so then I got 20 pi as my final answer. Ta-da! There it is. That was it. Pretty simple. Next problem. Now, this is actually like a normal problem. It's actually like, you know, a problem we would use shell method on, and it's not a big deal. No conversions needed. So here we go. We got 5e to the negative x squared. You say, that's not normal. Well, it's actually a lot easier than you think. Y equals 0, x equals 0, x equals 1, and then about the y-axis. Again, when I see this y-axis, I first think shell method. It's just kind of built into me. And maybe it'll be built into you as well. X times f of x dx. That was it. Very simple, very quick, very easy. Guess what these limits are here? Well, I have to draw to make sure, but I'm thinking it's the 0 to 1. But what are we looking at? What's the shape of this thing? Like, I could just get the answer. Here's your answer. You're done, right? Ta-da! Well, I mean, yeah, but what are we doing? What does it look like? You know, these are important questions. And so the function 5e to the negative x squared is actually a very classic one. It is a bell curve. And I'm doing the best bell curve I can here. Okay, so it's a bell curve, like from statistics and stuff like that. We're going from 0 to 1. So they're wanting this area in here to be revolved around, they said it, the y-axis. And so basically you would have this counterpart over here as well, find the volume. I'm going to draw it out actually like this. It has this kind of dome-like top here, and then we have this as a cylinder going down like this here. And I'm thinking this is a candle. That's basically just a candle with a wick right there, right? So we're finding the volume of a candle. I mean, these are real practical things. How much wax do you need for these candles? If you make a dozen candles, how much wax did you use, and etc. So, and my fire's not very good. Sorry, it's a really flaming fire. Let's just do the problem, okay? Let's just do the problem. So the 5 can come out to the front, making a 10. At least we can do that. And what we have now is a peculiar problem here. How do I solve this integral? Well, it's actually, you need to use u substitution. So let's actually do that. My u is equal to negative x squared. Du is a negative 2x dx. And something that you don't know about me, but now you're going to learn, is that I go one step further. Dx is equal to du over negative 2x. Now, if you haven't had me before, maybe you have, maybe you haven't, what I do is I go one step further so that I can not just try to figure out what's going on here, but I can actually just plug in my values, my equations, back in. Notice that this will literally be plugged in right there, and this will be literally plugged in right there. You don't have to think about it. You don't have to wonder, do I have to divide that number or multiply that number? Are these going to cancel out in the end? Don't wonder, because you just plug it in. You just plug it straight in, and we're not worrying here. So I have an x here. I have e to the u, and then I have a du over negative 2x. Now, some people don't like mixing u's and x's. Okay, they can not. I do. I mix them, and I'm okay with that. Some people also don't like me mixing the variables and stuff like that. Well, let me tell you what I do. I say x equals 0 and x equals 1 to remind myself to come back and convert that back later, okay? So some people convert to u equals something immediately. I don't even do that. Again, I'm taking forever on this just so I can explain to you my style so that whenever you're going, you're like, wait, he did something way different than what I'm used to. Well, yeah, I am doing something different. That's okay, because there's a lot of different ways to approach it. If you like your style, do it, man. I'm going to do my U sub. I think it's pretty easy. I'm going to keep doing it. So I plugged it straight in. I don't have anything to do there. I just plug it in, and oh wow, look, my x's, they cancel out one another. Woohoo! And this negative 2 is actually in the front now as negative 5 pi integral from, again, x equals 0 to x equals 1 of e to the u du. Normally I don't even write these here, but I'm super careful here because I know that I'm going to have to go back to my x values in a second. What's your integral of e to the u? Oh, I don't know. It's e to the u. Again, from x equals 0 to x equals 1. I'm not yet ready to plug it in. I need to go convert this back. And what was my u? It was a negative x squared. I'm just plugging it in. I don't have to solve anything. I just plug it back in, and oh wait, look, 0 to 1. And it's easy again. So I like to keep it as simple as possible, more plug it in, less trying to reason through it. Reasoning is cool. I like reasoning, but I really like plugging it in. I'm going to plug in this 0 as well here, by the way. I know that's kind of silly, but it actually is important because you will yield a value from it. Okay. So I got negative 1 squared. This really freaks me out. Is that positive 1? Well, this would be a positive 1, but that right here is 1 squared negative. 0 squared negative. Well, it doesn't really change anything here. That's still 0. But here it's definitely a negative 1. And here, that's just e to the 0. What's e to the 0? Anything to the 0. So 1. So 5 times 1. Oh, you notice I forgot something. I forgot something, didn't I? I always mess up. I got to mess up somewhere, right? Look, negative 5 pi. I forgot the pi. Oh, no. It's okay. It happens. All right. Like I have always said, wait to the end to see if I get it all the way or not. Okay, yeah, forgot about the pi. Hey, everyone, no one's perfect here, and I get that. So I actually got 5 pi and 1 over e here. If you want to make it look a little bit better, you can factor out the 5 pi and get 1 minus 1 over e. But again, you don't have to simplify it. You're probably good with that. If you type that in a WebAssign, it will work. You just have to type it correctly, of course. All right, well, I make small mistakes, but everyone makes small mistakes. And that's how we get through it together. Y is equal to the square root of 9x. Y is equal to x squared over 9. That's a 9. And it says going about the y-axis. Okay. I have no clue what's going on here, but I do know I could draw it. So I've got this square root, and it does something like that. I got a parabola, and it looks something like that. And I'm guessing they want this guy here and about the y-axis. Where are they colliding? Where are they intersecting one another? Well, I would have to solve. So let me go ahead and set them equal to one another. Well, the square root, I guess I can distribute to get something like this here. It's a little bit better. Move the 9 over, so I got a 27. You don't cancel x here. You factor or something else. What I'm actually going to do here is divide. So I got 27 is equal to x squared divided by the square root of x. What's going on is that I got a positive 2 and a negative 1/2. And so my power is going to be 2 minus 1/2 makes 3/2. So that's my ultimate final power for the x. 3/2. To solve for x, I now do 2/3 on both sides, canceling. So then I've got 27 to the 2/3, which you hope is a real number. And guess what? It is. Yes, it's a 9. I got 9. X equals 9. Here, let me verify. That looks a little weird, doesn't it? Yeah, it's a 9. Yeah, I can tell. Okay, it's a 9. We're good. 9. So basically right here where they're intersecting is 9. So we're going from 0 to 9. You can see that. So here we go. Volume. Oh, I want to show you what the volume looks like. I don't know. It looks something kind of like this. It's like one of those cup thingies, I guess you can say. Again, we're revolving about that axis here. There you go. All right, volume is 2 pi integral now from 0 to 9 of x times f of x. Well, what's my f of x and x and stuff like that, right? Notice I got 2 of them here now. So what do? What you actually need to do is notice that this f of x here is my height, right? It's going to change into, let me show you now. You're going to like this. It's a good thing. Top minus bottom, which we've done before. Top minus bottom. I have a top. I have a bottom. In fact, this square root thing here, that's my top, and the parabola here is my bottom. Top, bottom. Notice that I'm altering my formula a tiny bit, but it still works, and that's a good thing. We like that, and it's something easy that we've done before. So I got my square root of 9x, and then I also have my x squared over 9. Now pause for just a second. Notice that we're doing shell method, not disk method here. I am not squaring my top and bottom individually. That's not the formula here. I'm replacing f of x, which was not squared, into this thing. This is my f of x. This is my height, I guess you can say. My sum of heights or something. So I'm not squaring it. I'm not squaring each individual. I'm not squaring the whole thing. That was never part of the formula. That's a disk method thing. This is shell method. Okay. So I'm going to distribute this in, we got a 3x to the 3/2. Again, I got a 1 power and a half power makes 3/2 power. Distribute your x in here. I get 1/9 x cubed. And again, both of those are dx. Well, I don't need that. Now let's integrate. So I got a 2 pi in the front. Don't forget the pi, like I did last time. I'm going to add 1 to the power and divide by the new power. And so I get actually x to the 5/2 over 5/2. And I get this 1/9. And then I got x to the 4th over 4 from 0 to 9. Now the 0 will cancel everything out. So that's nice of it. Thank you, 0. So for the rest, though, the 2 actually comes to the top, making 6, divided by 5. So I got a 6/5 x to the 5/2. And then here the 4 stays in the bottom with the 9, making a 36 x to the 4th. Again, I'm just plugging in the 0 and the 9, basically the 9. And yeah, you're going to want some calculator action here. Just verifying my notes. Yep, everything looks great. So blah, 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 calculator, and I got 2187 pi over 10. I type it in, I get that answer. What? Your calculator doesn't do that? Oh no, you're getting a decimal, not a whole thing? Well, you don't have a Casio. I'm just joking around, of course. I love my little Casios. By the way, when I mean Casio, I'm looking at it right here. It's the FX115. Now, that's not allowed on exams and stuff. It's just my pocket calculator. It doesn't, I don't know. It's just a fancy little fun thing for $12 at Walmart. But I really like it. So how am I supposed to get this on any old calculator? Let's say I'm using Desmo Scientific or something like that. And I'm just going to remind you this. This is something I would say in pre-cal. This is what I say in any other class. When you're doing all this calculation here and you're plugging in your 9, forget about the pi. I know last time I forgot about the pi, and that was a mistake. This time I'm just saying literally forget about the pi. Do not write the pi in your calculator, and you're going to get this guy, math to frac, or you press the FD button or whatever it is, and you get this answer. Cool. Okay? We like that answer. It's a good thing. And then you put a pi in, because there was still a pi. I just didn't want to put that in my calculator. Almost every calculator, as soon as you put a pi in, it starts thinking, oh, they want a decimal. And no, you don't. You want a fraction. And so just remember that kind of stuff, okay? Okay. Oh, I have a little note here on this problem. This particular problem has the same answer twice. So very silly. You're going to type this same answer in for the next box. Part A and Part B. Type it twice, get the right answer, move on, okay? So what they're trying to say is compare disk and shell method. We're just going to do the easiest thing. I know that both of them will give you the same answer. Here it turned out to be shell method, but it's easier, so therefore I'll do shell method and be happy with it. Next question. Okay, so I got y is equal to x cubed, y is equal to 8, x equals 0, and then it says going about the x equals 5 line. Okay. Now this is going to be a little bit tricky, okay? So let's try to draw this and see what's going on. I got my cubic. Y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. X equals 0. So we got all this area in here. Where are these intersecting, colliding from one another? So I got 8 is equal to x cubed. When you cube root both sides, you get x equals a 2. So 2 there. Not the scale. There's 1, there's 2. There you go. Not the scale. And they wanted to revolve it around the x equals 5 line. And so that's way out here. So that's 3, 4, 5. They want to revolve it here. And what you end up with is straight something like this. And then we got kind of like a hole in the middle here, because what's going on the inside is it's coming down like that. So that's what I'm thinking is going on. There's your axis of rotation. There you go. So it's kind of like a disc on the outside, but you flip it over and it's, I don't know, it's just a little weird. Okay, how am I supposed to do this problem? Let's start with some first thoughts. So my first thoughts is to use shell method, because I got these x values here. So blah, 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 0 to 2, x, f of x, dx. Okay, so that's my first thoughts. Again, see, we got a top and a bottom, so we got to do that as well. That's my first thoughts. Now, how do we actually accomplish it? I can't really do that exactly, because this is the axis of rotation. What I need to do is move this over and shift everything over to the left by 5. I need to shift everything over to the left by 5. Now this is going to be a little bit strange, okay? I'm going to do this math. I have the right answer, but what's going to happen is that you'll have to adjust it accordingly. So let me show you how this works. I'm going to be very straightforward with you on this, okay? So I'm going to shift everything over, and I don't know why I put to the right. I'm actually going to the left. That's kind of weird. Whatever. So I'm shifting everything over. If I'm shifting things over here, let's say I got 2 and I'm moving it this way. What am I actually doing to that number? Wouldn't it end up being over here like a -3? So what did I do to that number to get it from here to here? What was the action that I did? I said -5, didn't I? I said whatever my x value, -5. Whatever my x value, -5. Pretty interesting, right? So what this does is makes it much easier. This is not an official formula, maybe not even an official method, but what I actually have for my answer is I go from 0 to 2 of x minus 5, and then I just proceed on with the rest of the problem as I normally would. Remember that this is top minus bottom. Top here is 8, bottom is the cube. So I got my 8 minus the cube. Top minus bottom. That's my f of x. And there we go. So what this does right here is that I shifted my axis. That's all I did. Everything else is the same. I know it seems almost too easy. Like, is that all you have to do? I mean, I got the right answer. So let's keep going. I'll show you how to do this. Obviously, at this point, because I have two factors, I need to FOIL it out. So I'm going to be multiplying these together here and getting a whole bunch of mess. So let's do that here. I've got 8x. I've got minus x to the 4. I got minus 40. And then two negatives make a positive 5x cubed dx. And that's still from 0 to 2. Let's integrate, because it's not too hard to do that. So I got x squared over 2. X to the 5th over 5. I got 40x. I got 5x to the 4th over 4 from 0 to 2. The 0 cancels everything, so I'm only plugging in the 2. And 2 with all this stuff is actually not too bad. What I end up with, if I use your calculator, is 504 pi over 5. But notice again, I got a negative. I got a negative 504 over pi. Can I have a negative volume? No. So you make it a positive, and you're done. The end. That was it. What they had done to make it positive is they didn't do x minus 5. They did 5 minus x. And then everything would be fine for them. You know, if you want to do that, that's fine. Is that a formula? I don't know. I just say shift that axis over. Everything else works. Maybe this is a bit more unofficial than others. But that's the quick way to do it. And it worked. And we like that. And we're going to move on. Okay? So try to keep it as easy as possible. Don't try to overcomplicate it. Next question. I got x is equal to 4y squared. I got y is greater than or equal to 0. I have x is equal to 4. It's a 4. It's a terrible 4, but it's a 4. And then I got going about the y equals 2 line. Let's graph it. Ooh. Okay, so what we have is this is actually a square root. If you divide by the 4 and square root both sides, you get something kind of like this. Y is greater than or equal to 0, so they're saying only above here. So all this, that would be a negative, right? Because you square root both sides, you get a plus and a minus. They're only wanting the positive. And x equals 4. Again, this is x and y still. I haven't changed anything. 1, 2, 3, 4. And there we go. So they're wanting all this stuff. Now they're wanting to revolve this around the y equals 2 line. So that's going to be 1, 2. And my guess is that if I put in a 4 over here, maybe I'm not guessing correctly. Here, let's back up a little bit here. Let's find out, where is this intersection right here? Where are they colliding with one another? So I got 4 is x, so I'm going to plug that in. It's equal to 4y squared. Divide the 4's out, square root, and you see that we get plus or minus 1. So basically, it's a 1 right here. They're wanting to go at 2. At 2 is going to be where I start revolving it. Okay, now if I'm going to revolve this thing, let me see if I can figure this thing out. So it's going to be flat on the outside, and then it has a smaller thing here, and it curves in like this. Yes, that's what it looks like. Okay, something kind of like that. Cool, so we got a picture. Everything's great. What are we going to do? What are we going to do? Look, this is our picture. Well, it looks like here that we're at 4, yeah? We got a top, we got a bottom, and it's revolved around a horizontal axis already. Now, I know that I can go and bring this into shell method mode, but I have to start doing some conversion things and da-da-da-da-da. Yeah, I'd rather just do it like this with disk method. So I'm going to use disk method. Now, in order to do disk method, of course, I have to shift everything down by 2, okay? And I'll probably get a negative answer because I didn't flip my top and bottom, that kind of thing. I'm already expecting it because I already know what I'm going to be looking at here, okay? So let's do it like disk method here. Disk method would be a regular pi, not 2 pi, but a regular pi, 0 to 4 of, again, my top squared minus bottom squared dx. I mean, that's the formula. So let's do that. 0 to 4 my top would be this guy here. Now, notice that I drew this as a square root, so I need to think of this as a square root. So that's y squared is equal to x over 4, square root both sides, and so you get the square root of x over 2. That's what I'm actually going to use as my top. Square root of x divided by 2 squared, right? That's part of the formula. I got to square them here. And then my bottom was just going to be a 0. So that's actually pretty simple. Squared dx. That's my answer, right? Well, no, because I didn't shift them down at all. I need to make them shift down. So my top and my bottom both as functions need to be minus 2 in order to go down some. So I'm going to say square root of x divided by 2 minus 2 and then squared. Same thing here. I started at 0, but I still have to shift it down by 2, so minus 2, and then square it. That's why I retain that 0. I don't just say, oh, there's a 0 there, so I don't draw it. Well, no, I use a 0 because I have to shift it down as well. It's still a function. That's why I say disk. Of course, this is washer. Yes, I know that. But I always use that same style, the washer style, I guess you can say, regardless of what I'm looking at. So this is your answer, and we should be done. I just have to go and do some math. Of course, here I'm going to have to FOIL that thing out before we do anything. And so I've got this squared, that one times this one. So I got a regular x over 4. And then I got my 2 here. 2 and 2 are going to cancel, but I got to double it, so I'm going to have another 2 square root of x. And then finally, 2 times 2 is a 4. And then over here, I got negative 2 squared should make a positive 4, right? Positive 4, but then a minus in the front means a minus 4 there as well. Thankfully, those guys cancel. Not that it really mattered in the end. Here, I got 1/4 and then x squared over 2. Here, I got a 2 in the front. This is going to be 3/2 over 3/2 from 0 to 4. We had established that the 0 cancels everything. This 2 right here combines with this 2 to make a 4 divided by 3. So I'm just trying to make this thing cleaned up a little bit. That's actually going to be an 8 down there. So I got 4/3 x to the 3/2, 0 to 4. The 0 again cancels, plug it in the 4, blah, blah, blah. I got a negative 26 pi over 3. What's your answer? A positive 26 pi over 3. The only reason why I got a negative, yet again, is because my top and bottom were flipped. When you shift this whole thing down by 2, what you're actually going to end up with is something down here like this. This is technically now my top, and this is my bottom because this one's further and closer. Further and closer. Now, does it matter? No. You know what to do. I'm just wanting to show and prove why it's happening. Okay. This has got to be the last problem, right? Okay, yes. Whew. These are some big sections. So, and expect that for, well, the whole class. So we got 0, 0, 5, 8. X is equal to y minus 7 squared. I got x is equal to 4. I got about the y equals 5 line. Let's draw it. I have this as a sideways parabola. Now, what's going on is this this minus 7 is actually shifting it to the right by 7 if you were doing a y and an x like that. So 1, 2, 3, 4, 5, 6, 7. Did I do 7? 1, 2, 3, 4, 5, 6. Yeah, I did. Okay. And then there's a parabola here, and everything's happy. X equals 4, 1, 2, 3, 4. And lines aren't perfect, but whatever. And it says about the y equals 5 line. Y equals 5. 1, 2, 3, 4, 5. I wonder, are they touching at 5? I think they are. Anyways, so about this line, that's what we're revolving around. So this is a weird shape, actually. It's going to be circular, but it's like a whole bunch of circles kind of like combining together kind of thing. And what's going to actually end up is that the top looks like a disc, but the bottom actually looks more like a donut. And so it has this donut shape. It's still going to be like a circle, but if you flip it over, it's going to have this kind of, I'm going to flip it upside down. it's going to have this kind of donut kind of shape, I guess you can say. Or maybe like a bagel. I don't know. There you go. There's your axis of rotation. That's probably not my best drawing. So it's kind of hard to imagine. It's like looking flat on it. You got two humps, and then you spin them around, basically. But that was, again, I flipped it upside down, so it's technically like this. Okay, so cool. Let's figure this thing out. I actually flipped it upside down on my notes as well to kind of emphasize a point there. Looking at this picture here, should I go with shell method, disk method, blah, blah, blah? Well, I think shell method should be fine. Notice that I did the y and the x differently than normal, automatically almost, because it was an x equals, and it kind of just felt like that was what they wanted. And so they're saying start here at 5, and I believe 5 is fine because this is 7, and over here is a 9. So what if I did, again, top and bottom, 2 pi integral from 5 to 9 of x times f of x dx. And again, redoing this, that's technically now, again, top minus bottom dx, okay? That's better. But again, remember that we're shifting it, right? So I'm going to be shifting it, I think, was it 4, 5? 5. Shifting it 5. Just looking at my notes here. Shifting it 5. I did something completely different in my notes. That's fine. Hopefully you get the same answer. I don't want to have to re-record this. I won't. If I get it wrong or something, well, we'll just figure it out together, I guess. So I'm going to shift it by 5. And am I using the x's correctly? No, these are y's technically. So I'm going to shift that by 5, y, and then I have my top and bottom. Right here we got a 4, and then we got all this mess up here. 4, and then I have my y minus the 7 squared dy. So this is my top, this is my bottom. I changed it from x's to y's because y's are technically correct. And this is my shifting right here, okay? This worked last time. I might get a negative or something. The way I did it here, I believe I did a disk method. What we're doing here is shell method right now. I think I did disk method on my paper, and I got a positive answer, so that means I did something right. So let's try to figure this thing out together. And I don't want to use blue anymore. Hold on. So there we go. That's a little better. So first off, I need to FOIL this guy out individually. So we're not even close to combining these guys together yet. We still need to simplify this one. That'd be a y squared, and then minus 14y plus 49. Distribute your negative. I've been known to make mistakes there even. So plus 14y minus the 49. And now I need to FOIL this guy out. Now you're thinking maybe the disk method was better. No, not really. I had square roots all over the place. It was crazy. So if you like square roots, do that. But here, at least we got some polynomials that we can work with. 4y minus y cubed plus 14y squared minus 49y. Now I'm going to do all these guys here. Minus the 20 plus 5y squared minus, what's 5 times 14? Come on, calculator. 5 times 14 is 70. So it's a negative 70y. And then finally, two negatives make a positive. 49 times 5 is 245 dy. Okay. All of this is polynomial land. It's easy stuff. I guess you can combine like terms even to make this a little better. Oh, there's another one right here. So let me use my calculator on some of this stuff. I know that I got a negative y cubed, and I can't get rid of that. My squares here will make a 19y squared. My y's, I got a 4 minus 49, and then I've got a minus 70 to make a negative 115y. And then my constants right here is a, what, 225? I sure hope I get this right. What were we going for? What was my limits? Here we go. 5 to 9. 5 to 9. Okay. Oh my. So here we go. Negative y to the 4th over 4. I got 19y cubed over 3. I got 115y squared all over 2. And then I got a 225y from 5 to 9. Oh man, this is a big calculator thing. So I'm going to type in all this stuff slowly, and hopefully I get the right answer here. So power 4, divide by 4, and then plus 19, and then times my 9 cubed, divided by 3, minus 115 over 2 times the 9 squared, and then plus 225 times 9. Let me write this down. 1377 over 4 minus, and now I'm going to plug in the 5 everywhere. My handy calculator here, I could just change those 9s into 5s, thankfully. So if I get it wrong, I'll be getting it wrong twice. Ha 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 ha. Okay. And so I got 3875 all over 12. Remember that 2 in the front. So I got 2 times, and I got the 1377 over 4 minus the 3875 over 12. I got it. I got it. Yeah. And I got it positive. Isn't that cool? Boom. And it's positive. Yeah, that's the correct answer, by the way. I have it in my notes. Awesome. Okay. Well, I was a little bit scared about that one. I know that it seemed like it was really big, but the other way that I did was no better, honestly. A couple things canceled, but you were dealing with square roots the whole way through, and it was not really that fun. So either way is fine. This is pretty straightforward. All right. We got done with that section, and that is a great feeling. So that's it. That's all I got right now. Thank you very much. Have a great day.